This first lesson in the bonding unit is going to be some review of some concepts you should already know from Science 10 and your science units in junior high. First thing we're going to look at is the Bohr model, and that's the typical planetary diagram that most students are familiar with from junior high. It shows protons and sometimes neutrons at the center of the diagram, and that represents the nucleus. Then the electrons are drawn typically as dots orbiting around the nucleus, so they're typically drawn on top of circles. An oxygen atom, which we can represent as just its elemental symbol O, would have 8 protons in the center, and I'm going to leave off the neutrons. Then around that, we draw our electrons. So first energy level has 2 electrons. The second energy level is going to have 6 electrons. That gives us our total of 8 electrons that we would want to match up with the 8 protons that are in the nucleus. So 2 in the first energy level, 6 in the second, 8 protons, and 8 electrons in total. Then our second example of the oxygen ion, O with a charge of 2 minus, would still have 8 protons in its nucleus, and we'll leave off the 8 neutrons. First energy level, again, 2 electrons. But this time in the outer energy level, instead of just having 6, we have 8 electrons. So a total of 10 electrons for the entire diagram means 8 protons and 10 electrons, an overall charge of 2 minus. An energy level diagram shows the same idea but is drawn just a little bit differently. Protons are usually placed at the bottom. Again, those represent the nucleus. And then electrons are drawn going up the diagram, moving away from the nucleus. If we did a sodium atom as our first example, sodium has 11 protons. So our 11 protons go at the bottom for our nucleus. 2 electrons would be in our first energy level, closest to the nucleus. Second energy level would have 8 electrons, and our last energy level furthest out would have 1 electron. A sodium ion, by comparison, which is Na1 positive, would still have the 11 protons in the nucleus, 2 electrons in the first energy level, and 8 in the second, but now that outer energy level is empty. So there's nothing in that last energy level. We just have 2 in the 8, so 10 electrons and 11 protons. That gives us the overall charge of +1 for the sodium ion. Let's do a couple of other examples of energy level diagrams. They take up a little less space. They're a little bit easier to draw. A sulfur atom is going to have equal protons and electrons. So sulfur, which has an atomic number of 16, will have 16 protons in the nucleus, 2 electrons in its first energy level, 8 electrons in the second, and 6 electrons in its outer energy level. A chloride ion, Cl with a charge of -1, must have an extra electron. So chlorine with a number of 17, 17 protons in the nucleus, 2 electrons in the first energy level, 8 in the second energy level, and typically, if we were drawing the atom, we'd do 7 electrons in the outer energy level. But because we want an ion with a charge of -1, we need an extra electron. So we need 8 in the outer energy level. So 17 protons and 18 electrons. That gives us the extra electron for the -1 charge. A magnesium ion will have a charge of 2+, if you look at your periodic table. Magnesium has the atomic number of 12. So we start with 12 protons at the nucleus, 2 electrons in the first energy level, 8 in the second energy level. And now we have our 10 electrons and 12 protons, which gives us the overall charge of +2. So just like the last metal that we looked at on the previous slide, the outer energy level is empty. There's nothing left in it. Our last example, the argon atom, symbol Ar, no charge because it's an atom. So from its number of 18, we can say 18 protons, 2 electrons in the first energy level, 8 in the second, and 8 in the third. So a total of 18 electrons and 18 protons. Some other terms you should be aware of are valence energy level, which is referring to the outermost energy level in a diagram, either in the Bohr or energy level diagrams, and the octet rule. The octet rule says that atoms or ions are most stable when the valence energy level is full. This is achieved by taking or accepting one or more electrons, or donating or giving away electrons. If we look at the example of the sulfur atom, like what we did on the last slide, we would have 16 protons, 2 electrons in the first energy level, 8 in the second energy level, and 6 electrons in the outer energy level or valence energy level. The octet rule says sulfur would be more satisfied or is more stable if it were to gain 2 electrons. So 2 more electrons would allow us to do a full valence energy level. So now 8 electrons in the last energy level means that we have a stable sulfur ion. The atom, which would have 16 protons and 16 electrons, only has 6 in its outer energy level, versus the ion, sulfur 2 minus, 16 protons and 18 electrons, so that the outer energy level is full.